In this video, we're going to solve equations with logs on one side of equals, and then we're also going to solve equations with logs on both sides of the equal sign. And we're going to start with equations that have logs on one side of equals, and I'm going to show you how to do this with the example, solve log of x plus log of x plus 1 equals 3. The first thing we do here is combine those two logs into one log using the product rule for logs. So the sum of two logs is going to be the log of the product, so we get log of x times x plus 1 equals 3. And note, since there was no base given on our log, that means it's a base 10 log, so I've included the base here because we're going to need that in the next step, which is to rewrite this in exponential form. And the exponential form is 10 to the third power equal x times x plus 1. Well, that simplifies to 1,000 equals x squared plus x. And then we can move all terms to one side and get an equation 0 equal x squared plus x minus 1,000. Now we solve this with the quadratic formula. And I plug the coefficients a equal 1, b equal 1, c equal negative 1,000 into the quadratic formula, and I get the solution as shown here in purple of negative 1 plus or minus the square root of 4,001 all over 2, and I use that nice tool at Math Warehouse. I have the link shown here. You can copy it down. I mentioned it many weeks ago when we were covering quadratics. It's a great tool to use online to check your work when you're finding the solution of a quadratic. At any rate, our next step is to check these answers. Now, the only practical way to check these is to turn them into decimal form. And that's what I've done here. Actually, the tool has done it for me, which is a nice feature of the tool. I get x equals 31.1267 and x equals negative 32.1267 and so on. And we check these answers by plugging them in. Well, if we plug in negative 32 point something, that will not work because we cannot have the log of a negative. So right away I cross off the negative answer. There's no point in even plugging it in. But I do plug in the positive answer. And I find that log of 31.127, I've rounded to 3 places, plus log of 32.127, which is x plus 1. When I add them together, I get 3.0000 out to 4 places, which matches exactly. So our positive answer is indeed a solution. We can also write that solution in radical form as negative 1 plus the square root of 4,001 over 2. In our next example, we solve ln of x minus ln of x minus 1 equals 2. A very similar problem. We round our answer to 4 places. The first thing we're going to do is combine logs, just like in the previous example. Using the quotient rule for logs, where the difference of logs is the log of the quotient, we get natural log of x over x minus 1 equals 2. Our next step is to write in exponential form. Well, ln means the same as log base e. So we have log base e of x over x minus 1 equal 2. The exponential form then is e to the 2 power equal x over x minus 1. Now if you don't like that e squared term, you can replace it with a decimal equivalent. And what I've done is replaced e squared with 7.38906. I included 5 places on that approximation since we want an answer to 4 places. And we'll see how this works out when we're all done. So I've replaced e squared with a decimal, and then you multiply both sides by x minus 1 to clear the fraction. So you get 7.38906 times x minus 1 equals x. And now we can solve for x. We use the distributive property, multiplying 7.38906 times x minus 7.38906 times 1 equal x. Then we want to get all x's on one side and the non-x terms on the other. So we subtract x from both sides and add 7.38906 to both sides. And this gives us 7.38906x minus 1x equal positive 7.38906. We then combine x terms to get 6.38906x equals 7.38906. Divide both sides by 6.38906 and we get x equals 1.1565. But we're not done yet. We have to check that answer. And when we check it, we plug in 1.1565 into our equation, and we get ln of 1.1565 minus ln of 0.1565. And then we get 2.0001, which is close enough. Tells us we have a solution. And if you notice, if we had left the e squared in, instead of turning it into a decimal, we would have gotten the answer e squared over e squared minus 1. And I checked out the decimal equivalent of that answer, and I also got 1.1565. So replacing e squared with the decimal out to 5 places gave us an answer that correctly rounded to 4 places. The last type of equation we're going to look at would be an equation that has logs on both sides. If there are logs on both sides, we should combine logs on each side so that you get an equation of the form log base a of u equals log base a of v. One log on each side. Once you do that, you just simply drop the logs or unlog both sides and you get u equal v. Then you solve your equation for your variable, and then you have to check your answer or answers because you often get non-working solutions. Here's an example. Base 3 log of x plus 1 equal base 3 log of 5x. Here we have it already in the form log of u equals log of v. We can just drop the logs or unlog both sides. And when we do that, we get x plus 1 equal 5x. Well, then we subtract x from both sides, divide both sides by 4, and we get x equals 1/4. But we do have to check that answer. And here, when we plug in 1/4, we get base 3 log of 1 plus 1/4, which is log of 5/4, equals base 3 log of 5 times 1/4, which is 5/4. So we have log base 3 of 5/4 equals log base 3 of 5/4. It checks out. So 1/4 equal x is our answer. Now we'll look at one last example. Solve natural log of x plus 2 plus natural log of x equals natural log of x plus 1. Well, our first step here is to consolidate the logs on the left side. Combine those two logs into one. We use the product rule. So we get natural log of x plus 2 times x equal natural log of x plus 1. Now we can unlog both sides. And this gives us the equation x plus 2 times x equals x plus 1. It looks like another quadratic. So we multiply out the left side, subtract x, and subtract 1 from both sides, and we get this quadratic equation x squared plus x minus 1 equals 0. Again, we use the quadratic formula because this does not factor. And plugging the coefficients in and simplifying, you get x equal -1 plus or minus the square root of 5 over 2. And we have to check both of these answers. And the way we can check them is to turn them into decimal form. The decimal form answers are 0.618 and also -1.618. Well, we can throw out the negative answer right away because we cannot take log of a negative. But the positive answer does work when we plug it into our log formula that we started with. ln of 0.618 plus 2 plus ln of 0.618 does equal ln of 0.618 plus 1. We get very close. 0.4811 equal 0.4812. Close enough. So we do keep the answer of -1 plus the square root of 5 over 2.